Welcome to our second lesson on electronics today. My name is Nicholas Okuthe. I want us to look at the second part of full wave rectification called bridge rectifier. Remember the first one was a center tapped transformer and two diodes, but here we have what we call a bridge rectifier. Bridge rectifier basically uses four diodes. If you look at my diagram, we have four diodes. There are D1, D2, D3 and D4. These diodes, in any cycle, we'll find that two of them will be forward biased and two of them will be reverse biased. Maybe looking at the first half cycle, assuming current was to flow in the direction shown by R1, which diodes are going to be forward biased and which diodes are going to be reverse biased? Let's see. We look at it in terms of current flowing in this direction. Then when current reaches point A, it will have there is a junction. There are two paths that it can follow. The first path is where there is diode D1 and the second path is where there is diode D2. But look at it, diode D1 is going to be forward biased while D4 is going to be reverse biased. So it means current cannot flow through D4. So instead it will flow through D1. Then if it flows through D1 to reach point B, at point B there are also two paths. There is the path that goes to the resistor and there's the path that goes through D2. But you can see there D2 is reverse bias, so current cannot flow through it. So instead, current will flow through the resistor R. Then after resistor it reaches point B, and at point B, D4 was already reverse bias, meaning current can't go back there. So instead, current will go through D3, then to point C. So in that case, we are seeing that in the first half cycle, D1 and D3 are forward biased. D2 and D4 are reverse biased. So current will not flow through those two diodes which are reverse biased in any way. So instead, the direction of current in the first half cycle will be from point A to D1, resistor diode D1, then through point B to the resistor R, then to point D, then through diode D3, and lastly to point C, where it can now go back to the source. But what about the second half cycle? In the second half cycle, the same thing will happen. When current reaches point C, in the second half cycle, we are assuming current is now flowing in that direction. Yeah. So when it reaches point C, it will find there are two paths, the path with the D2 and the path with D3. But how will it flow? It will find that D3 is reverse bias, so it can't flow through that path whatsoever. So instead, it will flow through D2 to point B. At point B, it will find D1 is reverse bias, so instead it will flow through to the load R. Then from R, it goes to point D. At point D, because D3 was already reverse biased, it won't follow that path, so it will go through D4. So we are seeing there that in the second half cycle, D3 and D1 are reverse biased, so current will not flow through them whatsoever. But D2 and D4 are forward biased, therefore current will flow through them. So what will be the direction of current? The direction of current will be from point C here through D2 to point B, then to the load R, then to point D, then to point D4, or through diode D4, then back to A. So you can see that in both cycles, current flows through the resistor R, B, R, D in that direction or in that manner. What about in the second half cycle? It also flows through the resistor R in the direction B, R, then to D. So that shows that in this kind of rectifier, current is able to flow to the resistor or to the load R in one direction only, which is the basis of the bridge rectifier. So you see, when we are explaining how rectification happens or how a rectifier is able to do the rectification, then we simply explain it in terms of how current flows in both cycles. Remember, AC has two cycles, and we call them the first half cycle and the second half cycle. So once current is able to flow through the load, which in this case we have used resistor, in one direction, then the rectification process will have been achieved. So we want to end this by looking at, summarize this by looking at an example here. And in this example, I have a circuit that is given like that, and we have two diodes, diode D1 and diode D2. So we are asked in the first question to determine the direction, to determine the current through all the resistors. We have three resistors here. When the switch is closed, so when the switch is closed, of course we expect current to flow, and current will flow, but then we realize that D2 is going to be reverse biased. So no current will enter through diode D2, and in that case no current will enter through 4 ohm resistor. Therefore current through 4 ohm resistor automatically is going to be 0 amperes. What about the 2 ohm and the 8 ohm resistor? These two resistors are in series, and therefore current through them is going to be the same. So current through the 8 ohm resistor is the same as current through the 2 ohm resistor, which is the same as the voltage 10 divided by the total resistor. That in series, so we just add 8 plus 10 plus 2. That will give us 10 over 10, and 10 over 10 is 1 ampere. So a current of 1 ampere will flow through 2 ohm resistor. A current of 1 ampere will also flow through 8 ohm resistor. Then the second part, they want something to do with the voltage. Now, because 4 ohm resistor voltage is going to be current through it times the resistance, but current through it is 0, so the voltage is also going to be 0. In the 8 ohm resistor, we'll take the current through it, which is 1, times the voltage across it, times the current resistance, which will give us 8 volts. While the 2 ohm resistor, we also use the current through it, 1, times its resistance 2, will give us 2 volts. And of course, if you add 0 to 8 to 2, will give us the total voltage in the circuit, which is 10 volts. The same question could be asked maybe in terms of bulbs. Maybe if a bulb is placed in place of the resistors, then you are asked maybe when the switch is closed, what observation will be made on the bulbs. Yeah. So of course, when you close the switch, this one will not glow because there will be no current through it. But the 8 ohm and the 2 ohm bulbs, maybe D1 and D2, will actually glow. I think with that, we are able to handle questions on capacitors. So now I want to look at, or go back to this meter bridge. I didn't talk about the display. The output display on a meter bridge would appear as given there. Yeah, it is if current is flowing in one direction, therefore the display will only occur on one side of the graph. Now, if we connect a capacitor across the road, the capacitor will do the smoothing, and the smoothing, this output display here will now appear like this when you connect a capacitor. So capacitor does the smoothing so that we end up with a smoothed output display occurring like that. Remember, capacitor is connected across the load. The CRO normally is also connected across the load. With that, I think we are good to go on the topic electronics. I want to thank you for listening and observing this lesson. Thank you.